subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Hello, good day everyone. Welcome to another tutorial by Smart Bukites in Advanced Engineering Mathematics. Today we are going to solve another question in second order non-homogeneous equation but using variation of parameter method. And this is the question we're given. Use the variation of parameter method and find the general solution of d2y by dx squared plus dy by dx minus 12y is equal to x. Okay, solution. This is the question. The right side is not equal to 0. We show that it's non-homogeneous. The first thing we're going to do is to bring out the auxiliary equation. That's here to say m squared plus m minus 12 is equal to 0. Same as quadratic equation. We are going to solve it, and after solving it we're going to have the roots of the auxiliary equation. So here we can use factorization method as well. We can say m squared plus 4m minus 3m minus 12 is equal to 0. Here we can say m into m plus 4 minus 3 into m plus 4 having 0. Total, I can say here m plus 4 m minus 3 is equal to 0, which is telling me that either m plus 4 is equal to 0 or m minus 3 is equal to 0. And this is telling me that my m is minus 4 or m is equal to 3. So this is my m1 and this is my m2, which is 3, and here which is minus 4. So here too I have two distinct roots. So my equation will be y is equal to the roots of my auxiliary equation are two distinct roots. So c1 exponential m1 is minus 4x plus c2 exponential of 3x. Y is equal to c1y1 plus c2y2. This is the relationship I'm going to use to determine the Wronskian matrix, something known as Wronskian matrix. So if I relate this to this, you can see that, and you can say y1 is equal to exponential of minus 4x, right? And y2 is equal to exponential of 3x. So for this variation of parameter, there's something we call Wronskian matrix. Wronskian matrix is determinant of y1 here, y1 prime, then y2 and y2 prime. This, you know, is a determinant of a matrix. So I have my y1 as the Wronskian matrix. Let's go. Is y1 is exponential of minus 4x. What's y1 prime? Differential of exponential of minus 4. Exponential of minus 4x is going to be minus 4 exponential of minus 4x. And y2 is exponential of 3x. It's differential, that's y2 prime. It will give me 3 exponential 3x. So this is a determinant of the determinant of this matrix. Here I will have then minus 4 times exponential of minus 3x, that's minus 4 exponential, yeah, but minus times minus will give me plus 4 exponential of minus x, because exponential of minus 4x multiplied by exponential 3x is the same thing to say exponential minus 4x plus 3x, all the x, which will give me exponential of minus x, because minus 4 plus 3 is minus 1. We all know this stuff. Yeah. So all in all, my Wronskian matrix of all is 7 exponential minus x. This is for the first part. Then there's something of the Wronskian matrix I'll find for 1 relation to y1, and then I'm going to find another one for 2. The relation for 1 says if I'm to find w1 in the place of y1 from the general Wronskian matrix, I'll put 0, and here I'll put function of x. This fx means what I have at the right side of my general differential equation. You can see here, this is the differential equation I have. What did I have at the right hand side? That's fx. If it's a trigonometric function, that's my function of x. If it's exponential function, that's my function of x. So here I'm going to have 0 fx, and here y2, and here y2 prime, which is 0. My fx is x, y2 is exponential of 3x, right? Yeah, of course. And differential of y2, that's y2 prime, is 3 exponential 3x. And the determinant 3 exponential 3x times 0 is 0 minus x exponential 3x. That's in general to say minus x exponential 3x. Then w2 is going to be y1 prime and 0 fx here. Hope you're all getting it. So this will give me, what's my y1? Exponential of minus 4x. And what's y1 prime? That's the differential of exponential of minus 4x, which will definitely be minus 4 exponential of minus 4x. And here 0x. The determinant of the matrix. Here I'm going to have x exponential 4x minus 0. There, this times this is 0, which is going to give me x exponential of minus 4x. So now I have w1 and w2. What I'm going to use with the Wronskian matrix is I'm going to find some parameters known as u1 and u2. How am I going to find them? I'm going to say u1 prime is equal to w1 over w, which means u1 is going to be integral of w1 over w. At the same time, u2 prime is equal to w2 over the general w. Therefore, u2 will give me integral of w2 all over w. So let's start with, but what will I use u1 and u2 to do? Because the general solution of my differential equation using variation of parameters is given by y is equal to complementary solution plus particular integral solution. And this complementary solution yc is what I've gotten from the above as c1 exponential m1x and c2 exponential of m2x. I've already gotten it because I have my m1 and m2. Then this yp is equal to y1 u1 plus y2 u2. Since I have my y1, I have my y2, I can now just substitute my u2 and u1 to find my yp, and I already have my yc. Then just insert them to find the general solution. Now what's going to be my u1? u1 prime is equal to w1 over w, in which I've already found my w1 to be what? Negative x exponential 3x. Yeah, here we go. Negative x exponential 3x divided by, what do I have as my w? Yeah, 7 exponential of minus x. That's over 7 exponential of minus x, which means I have minus x over 7 exponential 3x multiplied by exponential x, which means I have u1 prime is equal to negative x exponential 4x over 7. So to determine u1, I'm going to integrate this, which will simply be minus 1 over 7 into integral of x exponential 4x. So if we integrate this, we'll have u1 is equal to minus 1 over 7 into, what will I use to integrate this? Recall, if you have integral of u dv, you can say is the same thing as uv minus integral of v du, right? Okay, so for this, let me say let x be u. For this particular one, let x be equal to u, so du will be 1, and let dv be exponential of 4x. Then what is going to be my v? V is going to be the integral of exponential of 4x, which will definitely be exponential of 4x divided by 4. So putting it into this, I'll have what's my uv, that's x multiplied by exponential of 4x. So into this x, I have x exponential of 4x over 4. This is my uv, then minus integral of v du. Du is 1, so it's just v exponential of 4x all over 4. Moving further, I'll say u1 is equal to minus 1 over 7 into x exponential of 4x over 4 minus into exponential of 4x over 4 times 4, which is the same thing as just to say exponential of 4x over 16, since 4 times 4 is 16. Exponential of 4x times 16. So multiplying, I'll have u1 is equal to minus 1 over 7. Let me just multiply it directly. Minus 1 over 7 times x exponential 4x over 4. I will have minus x exponential 4x divided by 28. Then plus exponential 4x all over 16 times 7 is 112. So plus an integration constant, that's plus c, but let me say plus a, so constant number 1. So here I've gotten my u1. So then moving to u2 is equal to, u2 prime is equal to w2 all over w. So what have I gotten as my w2? From the above, we have w2 as x exponential of minus 4x. So x exponential of minus 4x divided by, what's my w? General w, 7 exponential of minus x. So it's 7 exponential of minus x. This will give me x exponential of minus 4x multiplied by exponential x divided by 7, which is going to give me u2 prime is equal to exponential of minus 3x divided by 7. So now u2 will be the integral of this. Therefore u2 is equal to integral of x exponential minus 3x divided by 7, which is the same thing as to say 1 over 7 integral of x exponential of minus 3x. let's integrate this as we just did earlier. I will say let u be x, then du be 1. Then dv is exponential of minus 3x. What is going to be my v? Exponential of minus 3x over minus 3. So u2 is equal to 1 over 7 into uv, that's x exponential of minus 3x divided by negative 3, then minus integral of v du. Du is 1, so it's just going to be v exponential of minus 3x all over minus 3. Moving further, say u2 is equal to 1 over 7 into x exponential of minus 3x over minus 3 minus, what is going to be the integral of this? Exponential of minus 3x, right, divided by minus 3 into minus 3. This will surely give me 1 over 7 into x exponential of minus 3x over minus 3, then minus exponential of minus 3x all divided by 9, right? Minus 3 times minus 3 is going to be 9. Then this will give me x exponential minus 3x, put the negative here, divided by 21, then minus exponential of minus 3x divided by 9 times 7, which is 63. Then plus the constant of integration. Here let me say b. There I put a for the first one when determining u1. So this is my u1 and this is my u2. So now moving to find the solution, y is equal to y1 u1 plus y2 u2. What's y1? y1 is exponential of negative 4x and y2 exponential of 3x. So u1, here is it, negative x exponential 4x over 28, negative x exponential 4x over 28, then plus exponential 4x over 112, then plus a, and u2 is equal to negative x exponential negative 3x, negative x exponential negative 3x divided by 21 minus exponential of negative 3x divided by 63 plus b. Now I'll just do the multiplication. For the first one, that's y1, u1 is going to be, what's my u1? Negative x exponential 4x over 28 plus exponential 4x over 112 plus a multiplied by y1, which is exponential of minus 4x. Yeah. Some PS here. You know that exponential of minus 4x is the same thing as 1 over exponential 4x. So if I say exponential 4x multiplied by exponential of negative 4x is the same thing to say exponential 4x over exponential of 4x, which will give me 1. So I hope you all get this. Before we got into multiplying y1 and u1. So multiplying y1 and u1, you will have minus x exponential 4x times exponential of negative x minus x over 28 plus exponential 4x times exponential of negative 4x is just the same thing to say exponential 4x over exponential 4x, which is 1 over 112, then plus a exponential of negative 4x. This is y1 u1. So now y2 u2 will be, what's my u2? Minus x exponential negative 3x over 21 minus exponential minus 3x over 63 plus b multiplied by, what's my u2? Exponential of 3x. So the same thing multiplying, I will have minus x exponential of minus 3x times exponential of 3x is going to be 1 over 21 minus 1 over 63 plus b exponential 3x. So the final solution, now I will just add these two together, in y is equal to y1 u1 plus y2 u2. So y1 u1 is this minus x over 28 plus 1 over 112 plus a exponential of negative 4x this is y1 u1, then y2 u2, this is plus directly minus x over 21 minus 1 over 63 plus b exponential of 3x. This is my y general. Rearranging, can match something together. Y is equal to a exponential of minus 4x plus b exponential of 3x, right? Then plus, I can say, okay, let's do it bit by bit. Then minus x over 28 minus x over 21 plus 1 over 112 minus 1 over 63. Then this will give me y is equal to a exponential of minus 4x plus b exponential of 3x. This is going to be minus x over 12. Then here is going to be minus 1 over 144. So this is the general solution. You can see that here, this part, a exponential 4x plus b exponential 3x resembles my complementary solution. Yeah, exponential 4x is my y1, here is c replaced by a there, here is c2 replaced by b there, exponential 3x. It's the same thing, c1 is a, c2 is b. So this is just the final solution of the differential equation, the second order non-homogeneous differential equation using variation of parameters method. I hope you enjoy this video and understand it. For any question, compliment, or misunderstanding, we will be waiting for you in the comment section. Thank you very much. See you in another video. Thank you.